future trend. That topic covers the hybrid manufacturing, bioprinting, and sustainability. The speaker for this content is Dr. S.T. Sancheti. Sancheti sir is HOD and professor in Mechanical Engineering Department of SNJB College of Engineering, Sanpa. He has total experience of HOD and professorships from 2017. He also worked as an associate professor and assistant professor from 2011. Dr. Sancheti sir completed his PhD in mechanical engineering from Christ University, Tamil Nadu. He has also completed his B and ME in machine design through North Maharashtra Institute. He has also fellow membership of Institution of Engineers. And one more thing is that he is a green belt holder in Six Sigma. So now I hand over this charge toward Dr. Sancheti sir to deliver his knowledge to all of our contender. So Sancheti sir, welcome to our program.
Yeah, thank you. Am I audible?
Yes, sir.
Okay,
Yes, sir.
Yeah, thank you. So, first of all, I'm really thankful for HOD Mechanical Bobre sir as well as entire team for inviting me as a speaker for this particular 3 days FDP. The topic what we are going to discuss today, it is the future trends, that is hybrid manufacturing, bioprinting, and sustainability. As already in last 2.5 days, every speaker has tried his level best to give you more insight about the 3D printing. So today, in this today's session, we'll focus on this particular point, that is hybrid manufacturing, bioprinting, and sustainability. As everybody know, sustainability is one of the buzzword in today's era. Even UN, United Nations also mentioned the 17 point on the basis of sustainability for the future. So let us move towards the point. Our agenda will try to cover the key concept related to hybrid manufacturing, bioprinting, and sustainability in additive manufacturing. After that, some of the emerging changes, trends, in which we'll try to explore the future direction as well as innovation in the field, which are the different challenges as well as opportunities available in this domain. And finally, it will be the question and answer session in which we'll try to answer whatever questions asked. Just have a quick recap that what is this additive manufacturing or 3D printing is called. So it is layer by layer construction process for material. Rest of the many our conventional processes are subtractive manufacturing processes, whereas this particular process is additive manufacturing process. So it is also known as additive 3D printing. So it is one of the key member of advanced manufacturing technology, and our focus area hybrid manufacturing, bioprinting, sustainability, and all the things. Okay. So first point is what is meaning of hybrid manufacturing. As everybody is aware with hybrid word due to the vehicle or automobile section, that hybrid means very simply where when we call hybrid means two or more type of things when it's come together, it is called as hybrid. So hybrid manufacturing, the best of both world. So definition for this hybrid manufacturing, that is combining the traditional subtractive manufacturing with additive manufacturing. So whatever our conventional or regular manufacturing, that we are combining with the help of additive manufacturing. Means our conventional manufacturing process is there already, but now we are combining it with the help of additive manufacturing, and purpose is ultimately efficient and precise versatile production. Advantages of this hybrid manufacturing: first one, will get flexibility in design, waste will be reduced, lower material cost, and shorter lead time. Technologies used along with this 3D printing, it is laser based 3D printing with CNC machining, directed energy decomposition with machining process. This hybrid manufacturing, which we are talking about, it can be utilized in following areas, but not limited. But nowadays, the application of this hybrid manufacturing is taken into aerospace, where the custom part, whatever part required as per the custom, some trials and error, these custom parts are used. Lightweight structure as well as high performance component. In automobile section, whenever the industries are looking for some prototyping, rapid tooling and customization of parts manufacturing, this hybrid manufacturing is providing a great help. In medical era also, custom implants, prosthetics with high precision, and in case of tooling, the manufacturing of tool with complex geometry. So these are some of the areas where this hybrid manufacturing is widely used, which we name as aerospace, automobile, medical, as well as tooling. Let us understand one case study, because here we have tried to give you the insight about some case studies also. So let us have the look on one case study also. This case study is used in GE's aviation approach. So in case of hybrid manufacturing processes, GE, everybody knows, it is one of the biggest player in aerospace applications also. So they have used the additive manufacturing and machining to produce the complex turbine blade. So on your screen you can observe the complex turbine blade shapes are available. So these complex blade turbine shapes are manufactured with the help of this hybrid manufacturing, that is conventional as well as our 3D printing. They have reduced the weight as a benefit, cost of material was reduced down, efficiency was also enhanced, and high performance is obtained. Key takeaway, what GE found by using this method, that hybrid manufacturing combines the speed, accuracy as well as material performance. Because conventionally, when we talk about this 3D printing, the question or the problem what we are facing, it is related to the speed of manufacturing. So in case of hybrid manufacturing, the speed point is covered and we are getting the product manufactured with significantly high speed. After the introduction of first point, that is hybrid manufacturing, second, which is one of the again impressive or lucrative area where this 3D printing is playing a significant role, it is bioprinting. This bioprinting is completely making some revolution in the healthcare application. So printing of living cells, biological materials to create tissues, organ and medical device. This is one of the emerging area where 3D printing is playing good role, and still there is a brilliant scope where we can take it ahead also. So printing of live cells, biological material to create tissues, organ as well as medical devices also. The material used for this bioprinting, bioinks composed of living cell, actual living cells, growth factors, and biomaterial. And its application we can found in tissue engineering, that is printing of skin, cartridge, bone, organ printing, early stage printing of complex organs. Still, it is in early stage, but the continuous effort or research is taking in this particular area where the actual live component of the human being can be 3D printed and can be used. So printing of skin is one of the area, then bone, organ printing, they are taking place into this. Application of this bioprinting in medicine also we will see. One is personalized medicine. Here, customized implants as well as prosthetic based on the patient specified data. As everybody knows, each human is a individual character or is different from the other. So here, personalized implants can be prepared with the help of this bioprinting in medicine field. Regenerative medicine, in which rebuilding damaged tissues using printed biological material. After that, drug testing, where printing tissues for drug testing, because nowadays lot of limitation as well as lot of control from the authorities, that testing of drugs, so printing of tissues for drug testing, which will ultimately reduce the need for animal testing also. Challenges what scientists found in this particular area, that is ethical concern, because till date that printing of organ, it is not accepted ethically, particularly related to the organ printing, scalability, and higher production cost. As this technology is very very new, we are finding these particular challenges which are particularly ethically, it is one of the big concern. Like if you remember, when the cloning concept was coming up and clone the human being, how it will be ethically acceptable. So this type of concern is again available here also, that how it is ethical to make that particular organ printing. Then scalability is one of the issue, and as on today the cost is very very high. And third concept what given to me for the discussion, it is the sustainability in additive manufacturing, and after that we will go each and every point in detail. So 3 points, their significance or their importance I'm trying to bring in front of you, so that it will be create interest for everyone, because I know listening into the online mode, it is one of the biggest challenge everybody is facing. So sustainability is one of the very very important. For sustainability, it is eco-friendly manufacturing. So additive manufacturing reduces the material waste as well as energy consumption compared to traditional methods. Recycling in additive manufacturing, so here the recycle material for 3D printing is possible, like plastic waste can be turned into filament and it can be used again, so it is a recyclable. Eco-friendly materials are also coming into the picture, in which biodegradable filaments and low carbon material are available. And energy saving, so additive manufacturing reduces energy footprints, especially in the lightweight component production. So these are the three topics on which we are going to talk today. That is three emerging areas, that is hybrid manufacturing, bioprinting, and sustainability. So let us understand each and every point in detail after knowing or understanding the topic. Am I clear? Can somebody can just chat or unmute and suggest me? Am I clear after
Yes,
this?
yes, sir.
Okay, thank you. Thank you, sir. Milind sir. Anyone else?
Yes, sir.
Okay, okay. Thank you, Nilesh. So, the circular economy in the additive manufacturing. So, circular or sustainability point already we are discussing. So, first point related to that, this is recycling. So here we can repurposing the plastic from e-waste or post-consumer products. It is possible. Material recovery, that waste material in new 3D prints. Local production is possible, that is reduce the transportation needs as well as carbon footprint, because the component can be print at the location itself and it can be put into use, and waste can be reduction. So it will help in the circular economy in case of additive manufacturing. So that point continuous we are using that sustainability, a case study in additive manufacturing in fashion area. So here Adidas, which is one of the famous company for the sports shoes and sports equipment, so they have used 3D printing to create a recyclable footwear. The footwears are manufactured till date with the conventional process. Adidas has used this particular technology to create a recyclable footwear. So, but naturally, it will reduce the wastage as well as customer fit shoes, because till date whatever shoes are available in the standard size and shape. So with the help of 3D printing, the custom fit shoes can be created. So particularly sports person, athletics, these people want a custom fit shoes, so that help them to use the shoes as per their requirement, exact requirement. And but naturally it will reduce the carbon emission also. So fashion industry is also moving towards the sustainability with the help of integration of additive manufacturing. So these are few case studies what we are discussing where till date they have successfully implemented the 3D printing technology in the different domain we are discussing. But still the journey is too long. Nowadays, we know it is the era of AI, and no sector in the world can be stay apart from the AI integration. Day before yesterday only, if you read into the newspaper, it is observed that whatever AI integration technology is used by a farmer in Baramati is appreciated by world technology giants, world technology leader from Microsoft. Satya Nadella also appreciated it. So 3D AI integration into this 3D printing, it is one of the key area of research in upcoming era, where AI algorithm will help us to optimize the design and automating the production processes, because till date whatever 3D printing we are doing, a conventional design we need to create with the help of some CAD softwares, and that importing that particular files into 3D printer. So if we assist that particular process with the help of AI, then it will optimize the design and automated the production process also. So this is one of the future trend or emerging direction coming up. Then 3D printing in construction. So around the globe, we may found that 3D printing application is used for buildings as well as infrastructure with sustainable material. Some of the cases are available where the entire house or entire that cabin is created with the help of 3D printing using sustainable material. And advanced bioprinting, as we have already discussed, that bioprinting it is still in the baby phase, but with the help of whatever development coming up, the day will be very near when printing of full organ for transplantation can be possible with the help of 3D printing. And smart manufacturing, because in today's era the manufacturing is nothing but integration of all the technology. So IoT integration can be possible, cloud computing is also possible, and robotics also possible to integrate into this additive manufacturing process. So these are all future trends as well as the emerging directions. As you already gone through lot of things into, so that's why just I'm trying to give you the insight into the newer points only. So, what are the challenges and opportunities available for this future additive manufacturing? So, challenges right now, there are limitation of materials. All the materials what we are using cannot be used for 3D printing. Scalability is issue because speed of 3D printing is very less, so scalability is one of the bigger issue. Regulatory hurdles are available, as well as the cost of component manufactured by the 3D printing, it is considerably costly. But opportunities available, innovation in the material science. So whatever problems we are getting with the help of limitation of material, the opportunities can be come to our door as there is a continuous innovation in the material science also. Few days back only, in one of the summit I met one startup where he come up with the unique idea that whatever shoes manufactured by his company, they are manufactured with the help of the plastic, waste plastic, and believe me, with the help of this new concept, he is getting very good revenue from the market. Opportunity, that is rapid prototyping as well as customization is possible with the help of 3D printing. And ethical consideration driving the healthcare innovation, it is again the innovation or opportunities available. So let us go into detail now. As I have given you a very clear idea about all the things, now we'll go each and every point in detail. So our first point of discussion was the hybrid manufacturing. So hybrid manufacturing, very very simple. Design or create a 3D complex part using CAD software. Use 3D printing to build a basic structure, layer by layer manufacturing. Refine the printed part using CNC or other subtractive methods. And finishing, that is, if you need it, you can apply surface treatment or additional processes as and when needed. So this is very very simple, that what is hybrid manufacturing. So design is our regular process where we are designing a complex 3D part using CAD software. Then 3D printing, build the basic structure, layer by layer manufacturing. Refine or machine the printed part using CNC or any other subtractive method. And in finishing, apply the surface treatment or additional process as and when needed. Which are the materials used in hybrid manufacturing? So hybrid manufacturing can utilize wide range of materials including metals, polymers, ceramics, composite, and each material is offering unique properties and application. So these are the different material that can be utilized into the 3D printing of hybrid manufacturing. Now let us go to second part what we are talking about, that is bioprinting. So for bioprinting, before we really go into the area, this is very interesting area. I will play one video and after that we'll go for this bioprinting discussion. Just a minute.
also just known as bioprinting, is a relatively new technology that, in
Audible?
theory,
Video is
would allow
audible?
humans to fabricate nearly any
Yes, sir.
tissue or organ from scratch. The fundamental idea behind bioprinting is quite similar to that of ordinary 3D printing, in which a material, usually plastic, is printed, one layer at a time. Instead of plastic, however, bioprinters use bioink, usually composed of cells suspended in a special gel known as a hydrogel, which helps to protect, nourish, and hold the cells together. Some bioinks use a single type of cells, while others contain multiple types of cells, or multiple bioinks are used side by side, each with a different cell type. There are three categories of bioprinting that I will be discussing in this video, which differentiate in the method by which they turn the bioink into a specific shape. Note that due to the fact that this is an emerging technology, the exact name and classification of various methods vary from source to source. The concepts, however, are universal. I choose to group the various bioprinting methods into the following categories: extrusion-based bioprinting, droplet-based bioprinting, and energy-based bioprinting. Extrusion-based bioprinting is similar to what most people would think of when they think of conventional 3D printers. It involves forcing continuous filaments of a material through a nozzle in a controlled manner to create a 3D structure. The material is bioink, which, as I said before, usually consists of cells and a hydrogel. The filaments are forced through a nozzle by either pneumatic pressure, which is basically air pressure, or mechanically derived pressure, which comes from things like pistons or screws. The bioink must be stabilized quickly, or else it will not retain its shape. The bioink can be stabilized in a number of ways, largely depending on the hydrogel that is being used. As an example, during printing, the bioink can be stabilized by spraying a mist with a cross-linking agent dissolved in it. By the way, cross-linking just means linking one polymer chain to another, and this is done to stabilize bioink. In contrast, droplet-based bioprinting deposits discrete volumes or droplets of bioink onto a surface. Droplet-based bioprinting methods include inkjet-based bioprinting, microvalve-based bioprinting, and laser-induced forward transfer bioprinting. As with extrusion-based bioprinting, the bioink must be quickly stabilized in order for the structure to retain its shape, and the exact manner in which this is accomplished depends on the hydrogel being used. Inkjet-based bioprinting shares a lot in common with traditional inkjet printing. Here's how it works. At a high level, a pulse of pressure is used to eject a droplet of bioink. The pulse of pressure can be generated in one of two ways, using thermal mechanisms or piezoelectric mechanisms. In the thermal mechanism, a small surface of the bioink is heated and vaporized to create a bubble, which occupies a larger space than the liquid bioink did, creating pressure, forcing a droplet of bioink out of the nozzle. Once the bubble collapses, a bit of bioink is sucked from the reservoir, refilling the chamber, and the process is repeated. In the piezoelectric mechanism, an electric current is applied to a piezoelectric actuator, causing the chamber to deform slightly, forcing a droplet of bioink out of the nozzle. By the way, a piezoelectric actuator is a device that responds to an electric current by stretching and bending. Then, when the electric current to the piezoelectric actuator ceases, the shape returns to normal, and a bit of bioink is sucked from the reservoir, refilling the chamber, and the process is repeated. Next, microvalve-based bioprinting involves small valves that can be accurately opened and closed with electromagnets to deposit droplets of bioink, which is under pressure, usually pneumatic pressure, meaning air pressure. Laser-induced forward transfer bioprinting uses lasers to accurately position cells on a substrate, or the place where the tissue will lie. Laser-induced forward transfer bioprinting consists of a laser, a focus lens, a ribbon, and a substrate. The ribbon could contain a sheet of transparent quartz glass with a very thin gold coating and a coating of bioink. When the laser reaches the gold, it heats it and greatly expands it, propelling a very small amount of bioink to the substrate, which will have been coated with hydrogel to dampen the kinetic energy of the droplet of bioink. This laser is quite precise, and hence this method is also quite precise. Finally, in energy-based bioprinting, a focused energy source, often a laser, is used to selectively solidify or stabilize a bioink. This method differs from extrusion-based bioprinting and droplet-based bioprinting in that the bioink is already in place. Perhaps the most notable method of energy-based bioprinting is stereolithography. In stereolithography, a laser is employed to selectively harden a small amount of bioink, which contains a light-sensitive hydrogel. This substance lies on a platform that is then moved away from the laser by a small amount. If, in doing so, the platform is immersed into bioink, then a fresh coat of bioink will flow on top of the now hardened layer of bioink, or if the platform has sidewalls, then a fresh layer of bioink can be coated separately. This process is repeated, eventually leaving you with a solid 3D structure once the liquid bioink is washed away. Each category of bioprinting has its own pros and cons. I won't bore you with all the specifics. However, as an example, laser-induced forward transfer bioprinting is precise and has a high printing resolution. Nevertheless, it is expensive, cumbersome, and time-consuming. Hence, different methods are used for different needs. Interestingly, there are approaches being developed that combine different bioprinting methods in order to maximize efficiency. Maximizing efficiency is crucial for bioprinting certain structures like organs. In general, organs must be printed quite quickly, and yet they have certain parts that contain lots of details that consequently require originate from certain types of stem cells. So, instead of being forced to take certain cells from a patient, like healthy cells from effects, then the drug is tested on humans. Often, there is no desired effect on humans, rendering the money invested in developing that drug a waste. In fact, 90% of drugs that showed promise in animals have no significant effects on humans. Occasionally, the drugs can even harm the humans being tested. This testing process is extremely expensive and inconvenient. With bioprinting, human tissue or even organs can be bioprinted that more accurately mimic the human condition and thus are more suitable for testing drugs. An organ is a simplified miniature version of an organ that aims to mimic a real organ so that it can be used to test a new drug. Technically, organs on chips are not inherently related to bioprinting, but bioprinted tissue can be used to enhance such devices with better positioning of cells and reproducibility. In the near future, it may be possible to have a nearly perfectly accurate system for testing drugs by linking organs on chips together in a microfluidic circuit, which would be known as a human on a chip. What this means is that to test an oral drug, for example, the drug could first be introduced to a partially bioprinted gut on a chip, which would absorb the compound and send it to a partially bioprinted liver on a chip, where it is metabolized. The metabolites are then sent to other partially bioprinted organs on chips, including the kidney on a chip, heart on a chip, lung on a chip, and bone on a chip. Throughout this process, the organs are tested for any intended or unintended response to the drugs. A similar pipeline could be used to test the safety and effectiveness of other forms of drugs. Note that in this process, organs on chips need not have the full functionality of particular organs. Instead, they only mimic the parts of the organ that are valuable in testing the effects of a new drug. Also, instead of introducing a disease to healthy animals and then testing various drugs to treat the animals, a disease could be directly introduced to a human on a chip, reducing the amount of unnecessary suffering. In summary, using bioprinting to test new drugs could be both more efficient and more ethical. In a similar way, the safety of new cosmetics could be tested without using animals, but using bioprinted tissue instead. Although it would come with important challenges of its own, bioprinting plants is a potential future application of bioprinting, with the possibility of creating new plant varieties with desired traits for agricultural use. Looking ahead, if or even when bioprinting fully
Like,
functional organs is common practice, the following questions naturally arise. Can bioprinting be used to create organs with abilities superior to the organs that we are born with? For example, can we bioprint eyes with supervision, or bioprint super efficient lungs, as found in elite athletes? Is such a use of bioprinting ethical? Will bioprinted organs and super organs be reserved for the rich? These are important questions that we must ask ourselves as this technology is further developed. Thanks for watching.
Yeah. Thank you for watching this particular video. Hope it has given you the clear insight about how useful this additive manufacturing or 3D printing technology can be. So, to summarize how it is done, as we have already seen into this video, that cell harvesting need to be done for bioprinting, that is collect the cells from the donor tissues. Bioink preparation, mix the cells with growth factors and biomaterials. Then 3D print, that is print the bioink layer by layer, and maturation that allowed the printed structure to grow and develop. So very interesting areas. Material already you have seen into the video. Cells, that is living cell from the donor. Growth factors, these are the proteins which stimulate the growth factors. Scallops, that is biodegradable material that provides structure, and hydrogel, that is water based material that mimic the natural tissues environment. Scalability of matrix of this conventional, that is traditional manufacturing, as well as this additive manufacturing, you can see that dark blue color is showing the scalability or the percentage of material waste. So here you can clearly observe that wastage of material in case of conventional material machining or conventional manufacturing is high, whereas with the help of additive manufacturing it is considerably low. As far as energy consumption is concerned, it is again very higher side when it is compared to additive manufacturing, and CO2 emission is also higher in conventional manufacturing or traditional manufacturing. So additive manufacturing shows the significant improvement in sustainability metrics as compared to our traditional manufacturing processes. Then where this AI can be used into the additive manufacturing. Sorry. So for design optimization, AI is very useful, where AI algorithm can create a efficient as well as lightweight design. Even also whatever traditional analysis we are doing in the ANSYS software, it altogether took hours and hours, almost 8 hours, 10 hours, 20 hours to complete the simulation. With the help of AI integration, it can be done very very quickly. So design optimization is possible, process control is possible, that is a real time adjustment to the printing parameters for getting optimum control. Predictive maintenance can be possible with the help of use of AI in additive manufacturing, and quality assurance part, that automated inspection and detect the defects coming up. 3D printing in construction. So here in the picture you can observe one imaginary site which is created with the help of 3D printing. So again, very very similar procedure what we are using for 3D printing. Design or create a 3D model to build a structure. Site preparation, that is set up a large scale 3D printer on the construction site. Here you can observe it is a set. Okay, so this is the large size 3D printer which is kept. Then printing layer by layer construction using concrete or other materials. So here you can see that layer by layer manufacturing is going on, and that construction is coming up. And finishing, that after this add window, door and other non-printed material to create a 3D printing construction. So again, very interesting area, like bioprinting was one of the interesting area. Use of 3D printing in the construction, again very interesting area coming up. This already you have seen into the basic of this bioprinted organ, that full bio transplant is possible. Complex tissue structure can be created. Organ on a chip can be created. That miniature organ model for drug testing that we have seen, and simple tissues like skin, cartilage, bone graft, etc. can be created. In the smart manufacturing part is concerned, we can use this very very important terminology in addition with this 3D printing. One is known as cloud computing, where we can store the centralized data and make the process. IoT sensors can be also integrated in order to have the real time monitoring of manufacturing processes. Robotics can be used for automated material handling and post processing, and digital twins can be created where a virtual replicas for simulation and optimization can be created. So in the 3D printing future, all these things can be connected together, which will definitely improve the quality of manufacturing, and whatever problem we are facing, that cost of manufacturing is considerably high, it can be coming down. So it is the smart manufacturing integration is possible. And to achieve this, more diverse and printable materials are needed, because today we are limited range of material. Inconsistency in the material properties, definitely it will create inconsistency of final product. Cost we have, and for critical application, getting certification with of the biometric these printed parts is one of the challenge. For regulatory, that quality control, we need to be ensure the consistency and safety for this additive manufacturing product. Intellectual property, protecting design in the digital manufacturing era is one of the challenge, because once that file is created, it can be protecting become very very difficult. 3D scanner can simply scan that particular component, and protecting your IPR, that is intellectual property, can become a challenge. Certification, even today there are no as such major standards available for giving certification for AI processes and materials. So this is one area where a lot of work is to be done for creating the certification. and liability, that is determining the responsibility for additively manufactured product failure. So these are the regulatory challenges along with the advancement of the area coming up. When we're talking about the costing, etc., so here you can observe a pie chart is created which is showing you the cost whatever takes place in the additive manufacturing. So equipment and material, these are the two main areas where majority of the task, around 68 percentage of the cost is consumed. Labor, then energy, and then maintenance. So potential cost reduction in the additive manufacturing can be reduced by reducing the cost of equipment and material cost, because for conventional manufacturing whatever material we are getting, the same material for additive manufacturing is very very costly. So if you really want to this additive manufacturing a commercial product, these two areas where the work is to be done and cost need to be reduced significantly. So these are the two areas where the cost is considerably high, around 70 percentage of cost is consumed. These are some of the advancement in material sciences is going on, and with the help of this advancement, we can create some good material. More possibilities are exploring so that this additive manufacturing can be done into various areas. So here you can observe on your screen some of the future product that can be created with the help of additive manufacturing, because advancement in material science are continuously expanding, and it is helping the possibilities where additive manufacturing can be used in various industries like robotics is there, everywhere it can be useful. Up to this, if you have any doubt, any question, you can ask, because we are coming towards the uh, next point. Before we are going for the next point, anyone is having any question or any suggestion to this particular point, up to this particular point is welcome, before we can go ahead. Yes, Nilesh ji, please.
Good afternoon, sir.
Good afternoon.
My question regards the additive manufacturing in construction. So that
Okay.
technology is existing or future technology? That means.
No, practically it is done at some of the places. Small construction is prepared with the help of 3D printing technology, so it is done. But still, we can say it is a baby product. Till we need to explore the technology, but it is done, already done.
But that type of construction having particular strength or not means.
That
So
is what, if you observe the previous slide, that certification, like as in the field of civil engineering, the strength is one of the major important area, and the whatever strength we are getting of the 3D printing, it is a questionable thing. So commercialized way it is not yet implemented, but definitely some of the trials are going on, and very soon we can see the 3D printed 3D printed houses can be as good as whatever conventionally we are preparing the houses or construction work.
okay, okay. Thank you,
Yes,
sir.
yes. Thank you, Nilesh ji. Anyone? So we'll let us move towards the next point from this presentation, because we are here to discuss about the future trend as well as whatever innovation, rest of the things, what is 3D printing and all the things you already learn from earlier renowned speaker who have contributed into this 3D printing area a lot. So I'm not focusing or repeating that particular points. So rapid prototyping and customization, because we have seen that a sports person, or for example anybody is want a customized thing, so rapid prototyping is helping it a lot. Simple, if you observe, nowadays customization is one of the keywords. सिंपल आपण पेन्सिल जी विकत घेतो लहान मुलांची, ती 5-7 रुपयाची पेन्सिल असते, तिला कस्टमाइज करून त्या मुलाचं नाव टाकून त्याला मिळाली, तर ती पेन्सिल तो त्याच्या आईबाबांना 15 रुपयाला पण विकत घ्यायला भाग पाडतो. सो लाईक दॅट दी प्रोडक्ट customization can be done with the help of this 3D printing very easily, because process is very much similar. Whatever concept is there, generate the initial product idea, then that idea is designed with the help of 3D modeling using any CAD software, print that particular product with the help of our AM technology, because otherwise for conventional manufacturing we need to create lot of toolings, die, etc. for that manufacturing. So in 3D printing we can directly go for manufacturing, test that particular thing, whatever product is created with the help of this 3D printing, it is suitable or not. So we can test it, evaluate, if needed we can refine the prototype, or okay we can do it, and otherwise this process can be iterated so many times until the final design is achieved. Because today the customer is looking for customization. Even if you if you observe the Tata's Nexon vehicle also, so lot of versions are available, lot of options are available for customization, and customer is a king, he can customize his vehicle as per his wish. So this type of customization is very easily possible with the help of 3D printing. Now coming up to ethical consideration in bioprinting is concerned. So organ allocation that need to be considered, that ensuring there should be a fair distribution of bioprinted organs. Human enhancement is possible, because people may be asked for addressing the concern about the designer body part. इफ यू ऑब्झर्व सम पीपल पिअर्सिंग करता किंवा वेगवेगळे टॅटू काढता, आणि जर त्यांच्याकडे हे काही ऑप्शन्स अवेलेबल झाले तर दे मे आस्क फॉर डिझायनर बॉडी पार्ट. सो अगेन इट विल बी अ इथिकल कन्सिडरेशन. एखाद्याला वेगळ्या पद्धतीने हात डिझाईन करून पाहिजे आणि तो सांगेल की मला तुम्ही बायो प्रिंट करून द्या, सो इट इज अगेन इथिकल कन्सिडरेशन. Animal welfare can be done. Whatever animals medicines or drugs are tested, it can be protected with the help of this bioprinted tissue, but the privacy is to be kept very properly. Protecting the patient data using personalized bioprinting is one of the challenge, because the security of personalized data is one of the major challenge or ethical point where the people need to be keep focus on to. After this, the future research direction, already whatever points we have discussed today, they are in the implementation stage. Still the final output or final product is not reached. Still it's long way to go to reach up to the product satisfaction level to the individual market. But these are again some areas, maybe down the line 15-20 odd years we can see that multi material printing. So today what we are doing, we are doing with the help of a single type of material is used for single part. So multi material printing, it can be coming up where the system will be designed for seamless multi material integration. Then bioelectronic interface, so merging the electronics with the bioprinted tissues. Few days ago, Elon Musk has given this type of indication that an electronic chip is on the verge of developing. That chip is fitted into the human brain, and whatever things we want to train, it can be fitted into that chip, and human can uh, be a master into that particular part. So integration of this 3D printing with the bioelectronic interface is one of the future research direction. Then on-site resource utilization, very ambitious term, that 3D printing using material found on site, means whatever material is available, can we do the 3D printing with the help of that material. So for example, on Mars, a lander is there and he got some material, so the 3D printer, whether he is capable of making the part with the available material. And self healing, so create the material which can repair themselves. If you remember the movie Mission Mangal, in that particular movie, this self healing component material concept is shown, like that sheet, if it is torn out, or if it is having some issues, the material is having the property, it can be making self healing. So this self healing material can be created which can repair themselves, so it will be reduce the time of maintenance as well as failure. So very very interesting future research where the scientists are looking for, and down the line 15 odd years we can see some of these things are come into the existing. So multi-material printing is quite easy, comfortable. Bio electronic interface, already work is going on the electronic interface with the human, just need to attach with the 3D printing or additive manufacturing. And self healing material, this concept is already done or used into the research. So to the closing remark, I am coming up that future of the hybrid manufacturing. So integration, we need to do hybrid, bio and sustainable additive manufacturing that will reshape the production across the industry. As we have seen these three terminologies into today's presentation, hybrid is there, bio is there, and sustainable is there. And when these three technology, or when these three terms will come together, it will definitely reshape the production across the industries. When it comes to innovation part, already we have seen lot of fancy innovations are available. Continuous advancement will open the new possibilities into design and functionality. Additive manufacturing will play a crucial role in creating more sustainable manufacturing future. And collaboration, where cross-disciplinary effort will drive the next wave of additive manufacturing breakthroughs. So these are the important point what I thought I should put in front of you. Anything, any point want some discussion? I'm available. Hello, Milin sir. Hello.
Hello.
Yes. Uh,
Is it my voice
sir.
audible to all of you?
Yes, sir.
Hello.
Yes, sir.
Okay. Is anybody have questions on regarding topic? Please may I ask to sir. Hello. Hello. Is anybody have any question or doubt? Please ask to the sir. Hello.
Yes, Milin, you are audible.
Is anybody has any doubt? Please ask question.
Okay, so should we stop?
Sir, just 1 minute.
Yeah, yeah,
Uh,
please.
okay. Uh, so today we are going to wrapping our program in adventure of additive manufacturing. I especially thanks to all of the speakers from day one who gives us their valuable inputs and outputs in current topics. I also especially thankful for all our principals and principal ma'am Dr. S.P. Deshpande and project director Mr. P.M. Deshpande who give us opportunity to arrange the stream of session in our program. I also thankful to all participants who have their give time to contribute in their FDP program. And not least, but I'm also thankful about my departmental colleague for their contribution in success of that program. I'm also thankful to all the uh, participants. Thank you, Sancheti sir. Okay. Then is one more note for that. There should be a link on a FDP group, WhatsApp group, about the MCQ questions regarding to all the 3 days topics. And after solving that MCQs, all the participants will get the certificate about that FDP program.